All right, so we're going to be taking a look at week 7, which was February 15th to 19th. The homework that was assigned Wednesday was page 379, numbers 30 to 60, multiples of 3. For numbers 30 to 42, you should have had no difficulties. I will be providing answers for 45 to 60 just because some of these examples we hadn't quite had a chance to go through yet. It's looking at 45. We have tangent squared of x minus tangent squared of x times sine squared of x. So we want to factor out the greatest common factor between the both. So notice that they both have a tangent squared in common, so we'll take that out. Okay. When you factor it out, you're basically dividing it out. So keep in mind here, tangent squared of x, factor out a tangent squared of x, and you're left with just 1. Factor out the same quantity from the second term, and you're just going to be left with minus sine squared x. Okay. Now, if you think back to Pythagorean identities, we have cosine squared x plus sine squared x is equal to 1. We want to get 1 minus sine squared x, so we'll subtract sine squared x from both sides. And that'll leave us with cosine squared of x is equal to 1 minus sine squared of x. So this right here is the same thing as this, so it will get replaced with cosine squared of x. All right, so in the next line, we still have the tangent squared of x that was on the outside. And the entire quantity just is going to become cosine squared of x. Okay, and then we're going to convert everything into sine and cosine. So tangent squared of x is the same thing as sine squared of x over cosine squared of x times the cosine squared of x that was already there. We can put that over 1. The two fractions are being multiplied, so we can cancel top, bottom, and diagonally. So then the final answer will just be sine squared of x. Final answer. Okay, let's move on to example 48. We have cosine squared of x plus cosine squared of x times the quantity tangent squared of x. Very similar to the one we just did. We're looking for the greatest common factor that we can factor out from both. In this case, you'll notice that they both share cosine squared of x, so that's what we're going to factor out. If you factor out a cosine squared of x from cosine squared of x, you're going to be left with positive 1. If you factor it out from the second term, you're going to be left with tangent squared x. Okay. Going back to Pythagorean identities, remember that tangent squared of x plus 1 is equal to secant squared of x. So we can replace all of this with secant squared of x. Right? So we'll have cosine squared of x. All that will be replaced with secant squared of x. And then we'll break everything up into sine and cosine. Cosine squared of x is already written as cosine. Secant is the same thing as 1 over cosine squared of x. Put that over 1. Cancels in both directions, so final answer would just be 1. All right, taking a look at 51. We have tangent to the fourth of x plus 2 tangent squared of x plus 1. Okay. So we can FOIL, well, reverse FOIL, right? So we want to figure out what two quantities that'll be equal to. Keep in mind, this is sort of, if it helps, think of it as being roughly equivalent, to x to the fourth plus 2x plus 1, right? And we want to break it up into two quantities. So first term, what times what would give us tangent to the fourth? It would be tangent squared x. And then we're looking for what will multiply to give us 2, but when we add it, give us 1. that's just going to be positive 1 and positive 1. Okay, again, when we add them, give us 2, but when we multiply, give us 1. If you wanted to prove this to yourself, you can do FOIL here, right? First and first would give us tangent 4 to the x outer. This plus this would give us tangent squared of x. Inner, this plus this would give us tangent squared of x. Combined would give us 2 tangent x, and then last, 1 times 1 would give us 1. Okay, just a little proof in case you guys didn't believe if the FOIL would actually work out. All right, and then if you think back to Pythagorean identities, okay, tangent squared of x plus 1 is equal to secant squared of x. So we're going to replace all that with secant squared of x. So that'll just be secant squared x times secant squared x for a final answer of just secant to the 4th of x. Okay. Move on to secant 4 to the x minus tangent raised to the 4th of x. So this is actually a difference of perfect squares. It's sort of like this. Let me show you guys. Okay, I'll take this should have been b squared. Okay, so we're looking basically for some quantity times itself. That'll give us secant to the 4th of x, which will be secant squared x. Same thing with tangent to the 4th minus tangent squared of x. And then 1 is minus, 1 is addition. And this is actually supposed to be a 2. Okay, once we have that, here's where it gets a little bit tricky. So they sort of look like they might be Pythagorean identities, but they don't all quite match up. So if you go back, so we have tangent squared of x plus 1 is equal to secant squared of x. Okay, so what we're going to do here, we have, let's say, subtract tangent squared of x from both sides. That'll cancel. We'll be left with 1 is equal to secant squared of x minus tangent squared of x. We can replace that with that one right there. So all of that will get replaced with 1. And then we'll still have the other one, which was secant squared of x plus tangent squared of x, which looks like it might be a Pythagorean identity, but not quite the way it is. Okay, let's go back and look at this. All this is equal to secant squared of x. So we're going to plug all of this, where we see secant squared of x, into the original one. Okay, so we're going to have, let's see, tangent squared of x plus 1. Again, that replaces all that. And then plus tangent squared of x that was already there. And we'll combine like terms. So the constant goes by itself. And then 1 tangent squared of x plus another tangent squared of x is going to give us 2 tangent squared of x. Okay, that'll be the final answer. I will say this problem is probably one of the more complicated ones. Okay, taking a look at F57. We have the quantity sine of x plus cosine of x being raised to the second. Remember, the exponent just tells you to multiply the base by itself that many times. So if we were to rewrite it, it would be sine of x plus cosine of x raised to the second, which means we're going to multiply the base 2 times. Sine of x cosine of x, and then we're just going to FOIL them together. So first terms will give us sine squared of x. Outer terms will give me sine x cosine x. Inner terms will give me sine x times cosine of x. And then last terms will give me cosine times cosine, which will give me cosine of x, cosine squared of x. Combining like terms, we have these two right here, which will give us 2 sine x cosine of x. And keep in mind, sine squared of x plus cosine squared of x is a Pythagorean identity that's equal to 1. So we can just bring that out front. And that'll be a final answer. 1 plus 2 sine of x times cosine of x. All right, let's check out the last problem, number 60. All right, so we have the quantity 3 minus 3 sine of x times the quantity 3 plus 3 sine of x. So we'll FOIL it. First terms, 3 and 3 will give us 9. Outer, 3 times positive 3 sine of x will just give us positive 9 sine of x. Inner, negative 3 sine of x times 3 will give us a minus 9 sine of x. And then last, negative 3 times positive 3 will give us a negative 9 sine squared of x. Okay, combining the two middle terms, the common terms, like terms, will cancel out, and we'll be left with 9 minus 9 sine squared of x. We're going to factor out what they have in common, which is a 9. And we'll be left with 1 minus sine squared of x, which if you go back to the Pythagorean identity, sine squared of x plus cosine squared of x is equal to 1. We're going to subtract sine squared from both sides. That cancels, we're left with cosine squared of x is equal to 1 minus sine squared of x. So all of that will get replaced with cosine squared of x for a final answer of 9 cosine squared of x.